Hello, it's me, Maria Sandoval, and today we will be going over the extra credit portion of this chapter. So you don't really have to watch this, but I do. So we're going to be starting off with identifying the correct quantum numbers, and we're going to be going over quantum theory. So we're having a sample problem, and we're asking you to find what is wrong with each of the following quantum numbers, designations, and or sublevel names. So here is our A, B, and C. We have the N, L, M1, and the name of this sublevel, or designation. So starting with A sublevel N equals 1. So it can only have L equals 1, not L equals 0, not L equals 1. So the only possible sublevel name for this first one is 1S, so it cannot be 1P. For B, a sublevel with L equals 3 is an F sublevel to a D sublevel. So it can be D, and it should be F because it's moving down to D. It can already be at D. So the name should be for F. C is a sublevel with L equals 1 and can only have M1 values of -1, 0, or +1, not -2. So this is incorrect here. So in the first two, it was our name. And in the last one, it was our M1 that was actually incorrect. So, since we're talking about the designation or the sublevel names, I'm going to be talking about a few of the sublevels today. I'm trying to ask it. Okay, so let me go forward. So, we're talking about the 1s, 2s, and 3s orbitals. So here, you can see that our N equals 1, our L equals 0. So our N1, L0. Here, N2, L0. Here, N3, L0. Here, N1, L0. Here, N2, L0. And here, N3, L0. So these are the same graph. These are the same type of graph. And these are the same type of graph. So this is our 1. Since both of these have 1, this is our 1s orbital. These both have 2, so this is our 2s orbital. These have 3, so this is our 3s orbital. This is our 1s, 2s, and 3s orbitals, shown here. Moving on to the 2p orbitals. So our N equals 2, and our L equals 1 here, giving us our 2p orbitals. Figure A is showing us it in a graph, and figure B is showing us a cross-section of what the electron cloud depiction would look like. So this is what, if you were to get the cloud that you have your protons and neutrons in. Your electrons are not in one space. It's kind of just like a general area. So say that this is your electron cloud, and here is your protons and your neutrons. You cut that in half, and this is what it's trying to show you. So the accurate probability contour is trying to show you the curves and everything of this electron cloud. D is the stylized probability contour. So it's not as accurate as the previous one. And then E is our 3p orbitals, showing us our suborganizations of p. So all of this is 2p orbitals. This whole page is showing you a 2p orbital. Moving on, we're talking about our 3d orbitals. N equals 3 and L equals 2. So this is our graph, and then showing us down here B through I are some forms of the orbitals that we're going to be looking at. So once again, we're talking about our proton and our neutron in our general electron cloud. We're going to cut that in half, and we're going to be looking at this cross-section of our electron cloud. And in figure B, it is showing us that. It's showing us what our cross-section of our electron cloud would be depicted like. C is the accurate probability contour, which is showing us how our electron would look. D is the stabilized probability contour, stylized probability contour, which is probably not as accurate as our accurate one, but it's showing us what it would look like. E is it again from another angle, so same with F, G, H, and I. These are all showing us the different types of orbitals that can be found in 3D orbitals, or different types of forms that can be found in 3D orbitals. I is specifically showing us the 5D orbitals. Moving on, we're talking about the summary of quantum numbers and electrons and atoms. So first we're going to have our name, symbol, permitted values, and our property. So talking about principal, our symbol is going to be N. Our permitted values will be positive integers, integers such as 1, 2, 3, 4, 5, 6, 7, 8, but you wouldn't find something like -1, -2, -3, or so on. It would have to be a positive. The property is our orbital energy and size. Moving on to angular momentum, our symbol is L, and the integers are from 0 to n-1. Our property of this is the orbital shape. The L values 0, 1, 2, and 3 correspond to S, P, D, and F orbitals retrospectively. Moving on to our magnetic moment, the symbol is ML. The integers from -L to 0 to +1 are our permitted values. The property is the orbital orientation. Finally, our spin, the symbol is MS. The permitted values are +1/2 or -1/2, and the property is the direction of e to the negative spin. So, another graph we're going to be looking at here is our angular momentum quantum number. So, angular momentum quantum number, our L. So we have 0, 1, 2, and 3. The shape of these orbitals are SPD because the values of 1, 2, and 3 correspond to SPD and F orbitals respectively. Sorry. So our 0 is S, our 1 is P, our 2 is D, and our 3 is F. The orbital orientation of these is 1 for 0, 3 for 1, 5 for 2, and 7 for 3. And the maximum number of electrons in these is 2 for 0, 6 for 1, 10 for 2, and 14 for 3. Thank you so much for listening with me today. And I hope you guys have a great day. And I hope you learned a lot, because I learned a lot too. I just want to double check that we didn't miss anything, because like I said, my computer has been giving me some problems. And I'm a little bit sick, so I'm not on my best game. 1, 2, 3, 4, 5. Okay, yes, we've gone over everything today, and I hope you guys have a great night, and that you learned a lot, because I learn a little bit more every time I do these videos. Bye. Sorry about being so sick.